Hello, everybody. I'm on campus today. It's weird. There's no cars in any of the parking lots. The buildings are all completely dark. All right, Holman Hall is completely dark except for the light on in a couple of offices. And I feel really bad because campus is so beautiful right now. All of the trees are blooming, all of the shrubs are blooming, everything, the tulips are up, everything's pretty, and no one's here to enjoy it. But I hope you guys are all still doing well at home. I hope that there has been no mutiny in your households, that everyone can still tolerate their parents. Keep your parents indoors, please. All right, protect the old people. Today we're going to start talking about data analysis. All right, so we're getting to the statistics part of class now. We won't be doing this in SPSS today, but I will show you in the future how to do this in SPSS. Remember that I'm no longer requiring you guys to do the SPSS for your data analysis. We're going to find a workaround for that. But I know that some, and that some may be a very small number of you, but some of you do want to learn SPSS, and I don't want you guys to miss out on that opportunity because of this virus. So in later lectures, I will find a way to show you guys how to do this in SPSS in case you want to. And when we do that, we'll pick up how to do these things that we're talking about today in SPSS. But today we're just going to talk about conceptually, all right, what are these descriptive statistics and when are they appropriate to use? And we'll talk about graphing a little bit, which is a chapter late in the textbook, but we'll bring that in to talk about today. All right, one thing I want to point out, when we talk about statistics in this course, I'm going to work from the assumption that you guys don't remember anything from your business statistics classes. So as far as what you guys need to know for exams and that sort of thing, it's only going to be stuff that we cover in these recorded lectures. All right, I'm not going to draw on anything that you may or may not have retained from a previous statistics course. All right, so let's just buckle up. All right, the statistics are here. We can get through it. All right, and luckily now you can watch these videos as many times as is necessary to learn it. I will also be, I don't know how YouTube works, to be honest, but I'm going to try to add videos to the channel or something. At the very least, I'll give you guys links to videos where other people with better tools than I have at my disposal have created videos to refresh students on how to do the statistics that we're going to talk about. All right, and so you'll have these lectures, and if I'm not clear, then I'll provide you some other resources to help you guys learn this stuff, okay? But first, a polling saga. All right, so this is an example to keep the sampling sort of stuff that we talked about 2 lectures ago fresh in our minds. This is from an example from the fall semester. So it's something that happened late in the fall semester when the impeachment trial was going on. All right, and so there was all these polls happening at that point in time about what proportion of Americans approved or disapproved of President Trump being impeached by Congress. All right, and so this example that we're going to get to on the next slide, that's the context. All right, so that's what's happening. Okay, so I don't remember the exact numbers. You can see the timestamp on this Facebook post, October 9th. Around when the impeachment trial was underway and things were, more and more evidence was being revealed, there were all these polls constantly by every news organization, every polling agency, trying to measure American sentiment towards impeachment. And surprising or not surprising, some news agencies were reporting higher numbers of people approving impeachment, and Fox's tended to be on the lower end. All right, so Fox tended to report that the majority of people were not in favor of impeachment, but then on October 9th, Fox News reports that just over half of Americans want President Trump impeached and removed from office. All right, and this was this sort of, watershed is strong, but it was this sort of striking moment because this is, the news organization that's often accused of being, propaganda is a strong word, but in favor of the presidency, right? So not ever being critical of the presidency. And here is this Fox News poll that's reporting that over half of Americans want the president impeached. All right, so on the next screen, we're going to see some comments, all right, that were under this Facebook post. I lied. The next screen doesn't have comments. The next screen has, remember I told you guys when you're looking at a poll that any reputable poll would give you information about the specific questions asked as well as the methodology, all right, the sampling procedure. And here we see Fox News is reporting the methodology, all right, and specifically they are saying that interviews were conducted among a random national sample of 1,003 people, all right. Remember I said 1,000 is going to be the key word oftentimes, or the key number rather, oftentimes when you look at these polls. They use landline and cell phone telephone numbers that were randomly selected using a probability proportionate to size method, which is more advanced than what we got into. But basically what this means is that they stratified all of the numbers basically by state and then drew numbers from each state proportional to the number of voters in that state. All right, and because there is this sample size of 1,003, we see margin of error plus or minus 3%. All right, so I wasn't lying before. This is very standard, sample size of 1,000. This is a yes/no question, and so because of that, you get this margin of error of 3 percentage points. All right, so I promise now for real. On the next slide, there's going to be the reviews, and remember that these are reviews on the Fox News Facebook page. So you can guess before we get to them how Fox News fans responded to the results of this poll, right? Reporting that over half of Americans wanted the president impeached. All right, here they are. 153 million registered voters, and you polled 1,003 people for your poll, nowhere near half of Americans. Half of voters? I don't think so. You didn't poll me. Here's the important bit, kids. They polled just over 1,000 people. Are we really supposed to consider that a significant sample? They always hide this kind of information at the end of the article. This person says, I wasn't asked. I would say there's no reason for impeachment. Fox News poll should reach over half of people. Oh, Fox News poll should read over half of people polled, not half of voters. My husband wasn't asked. My daughter wasn't asked. All right, so, oh, this person says, likely in New York City. These polls are usually sampled on the streets of very liberal cities. All right, well, actually, Fox News told this person exactly how the sampling was done if they had bothered to read it. But the question here, this is a handful of the comments that I screenshotted, but basically every comment was exactly the same. Just how are we supposed to take the results of 1,000 people and use that to make a conclusion about all of the people? All right, so is the sample too small? My answer is no. All right, as we talked about on, well, whatever, we don't have a schedule now. As we talked about 2 videos ago in the sampling video, 1,000 is a very typical common number for national polling. All right, and we talked about why. Because the goal of sampling is to get an answer from a sample and use that answer to draw an inference about the population. All right, and that inference making procedure comes with some error. All right, in this case, it has a margin of error of plus or minus 3%. All right, so if their sample reported that 50% of the sample said that they wanted the president impeached, that means we're 95% confident that between 47 and 53% of the population want the president impeached. All right, so that's where this 3% margin of error comes in. Increasing the sample size to 2,000, all right, only drops this margin of error by a little bit. And beyond that 2,000 mark, it doesn't matter, you're getting up to like 500,000 people or something. This margin of error isn't decreasing that much, and the cost to poll 500,000 people would be immense. All right, so 3% is a pretty good margin of error, all right, when you're trying to estimate something like this. All right, so no, I don't think the sample is too small. This is a common complaint. It's not a valid complaint. All right, and the second question that I have down here, would their sampling procedure produce a geographically representative sample? Yes. All right, so what they did here, where they basically stratified voters by state and then sampled within states so that each state was represented in the sample proportional to its voting population. This is making sure that they are not just getting, New York City or other very liberal cities, wherever those are around the country. They are getting voters proportional to the voting body, all right, across the nation. Another criticism that came up in the comments, they said, please now forward the sampling demographics. All right, Fox News didn't have to forward the sampling demographics. It was in the article. Nobody ever reads articles. They just read headlines. How many Dems and how many Republicans were polled? All right. However, thank you for saying that more than half of registered voters, which based on 1,003 people is by all means a leap of faith or fake news. No, sir. It is not a leap of faith. It is statistics. All right. Learn about them. All right. So to his question, we could ask, this is just like that example from the sampling video about, you know, did the AP have left bias because they had too many Democrats in their sample? This is from the Fox, the report. So like if you clicked on that Fox News story on Facebook, it would go to this report and you would be able to see all of the descriptive statistics for every question on the survey. All right, and so they asked, what is your political affiliation? And they found between solid and leaning in the Democrat and Republican category that 48% of their respondents were Democrat, 40% were Republican. I could not find a website that very succinctly and clearly stated this is the proportion of people who are registered as voters in each of these categories, but I did find data from Pew. All right, so you can see down here annual totals of Pew Research Center data. So this is data from the same year as this survey, and in this it asked people to identify themselves as either strong Democrats or Republicans or leaning Democrat or Republican. And if we look in this most recent time frame that we can compare to, we have, when we add up the strong Democrats and the leaning, this comes to 48% Democrats in the country. When we look at the strong and leaning Republicans, this comes to 39%. And if we compare that to these numbers, again, with the magic of random sampling, all right, with the magic of the laws of probability, we see that their sample has done a pretty good job, all right, of mirroring how the population, all right, and this was taken with a much larger sample, and it wasn't asking about impeachment, it was just asking, you know, how do you identify yourself? And you can also see that these numbers are pretty consistent over time, all right, so they're sampling, all right, with the exception of this one right here where it dips pretty low, all right, and down here too, they're generally finding pretty consistent numbers of people who identify as Democrat and Republican in their sample. All right, so no, I don't think that the result is due to oversampling of Democrats. The result is just what it was. All right, that week, the results showed that people were in favor of impeachment. All right, and so that's it. All right, you just have to accept the result of the study because that's what it found. All right, so why do I get so heated about this? Why? I mean, you guys can't see me. I'm all amped up about this. Why do I bother showing you guys all of these examples in class? The reason is because regardless of the topic, regardless about your personal opinion about impeachment or any of the other polls that get posted, there will be another poll today or tomorrow or next week, probably every day for the rest of eternity, that internet society will broadly misinterpret. All right, my parents will misinterpret it. All right, my mother-in-law certainly will misinterpret it, and then she will post 1,000 articles about it on Facebook. People do not broadly have knowledge about research methods. All right, they don't know about sampling and how random sampling works and why random sampling is good. They don't know about what an appropriate sample size is, but you do. All right, so you don't have to rely on all of this internet commentary to tell you whether you should trust the results of a poll or not. You can rely on yourself. All right, you can rely on your own critical thinking skills, and you can look to see, were the questions leading? All right, do I think that these questions were written in an unbiased and appropriate way? Was the sample drawn appropriately? All right, was the sample size an appropriate size? And once we start talking about these statistics, did they appropriately analyze their data? All right, so is the conclusion that they're drawing appropriate based on the kind of analysis that they did? These are all things that you should know by the end of this course, that whether or not you ever apply them to actually conducting research yourself are going to be important for just letting you avoid being swept away by internet insanity, all right, because people comment a bunch of garbage that they have no idea what they're talking about. All right, so I will step back. all right, from being angry at the internet. And on the next slide, we will get into talking about descriptive statistics. Okay, when we talk about data analysis, all right, we're going to talk about two broad kinds of data analysis. All right, and the first, what we're going to focus on in this video is descriptive statistics. All right, and so what descriptive statistics do, as the name implies, is they describe or summarize your data set. All right, and so importantly, this is focused only on the people from your sample. All right, it's simply saying, what did the people who answered my survey say in response to these questions? And it doesn't try to do anything more than that. All right, it's simply describing or summarizing the kinds of answers that you saw. Importantly, so importantly, the descriptive statistics do not make inferences about the total population. All right, so we're going to see that the mean is a descriptive statistic, and if you find on average that the people in your sample had a mean response of, I don't know, they have 2 packs of toilet paper at home, that does not mean that we infer that the entire population has 2 packs of toilet paper at home. It simply is saying that the people who took our survey, on average, this is what they said. When we want to make this inference, and we do want to make this inference, that is something that we want to do. That's the goal of doing the study, is to take what we learned from our sample and draw an inference about the population. But in order to do this, there are some additional steps that have to be taken. We're going to get to those additional steps in a couple of videos. Today, we're focused only on summarizing the data set. All right, so what we're doing with these descriptive statistics is we're providing summaries about the sample and the measures, all right, that we took. So when I say summaries about the sample, it means that we might be reporting things like what proportion of the sample was male, what proportion of the sample was female, what proportion were seniors, what proportion were Greek, etc. So providing summaries about the specific people who took the survey based on how they answered the demographic questions. And then we can also provide summaries about the measures, like in our sample, what proportion of respondents had taken ADHD medication? Or in our sample, what proportion of students report that they have sold their ADHD medication to other students? All right, and the way that we provide these summaries is through several different kinds of statistics. You can talk about the distribution, right, which is summarized with the range. What was the low answer and what was the high answer? All right, so how much difference was there between the lowest answer and the highest answer? We're going to talk in this video more about central tendency. All right, so how do we report what's average? And we already talked about this in class a little bit, so to an extent this will be a review, but we'll also talk about some additional things we haven't mentioned in class yet. And then we will talk a little bit about dispersion, all right, and what is variance and standard deviation. We are not going to focus on calculating these things by hand. I want you to focus on conceptually. All right, what do these things mean? What do they tell us? Why do we care about them? All right, that's what we're going to focus on. All right, just to reiterate something I said on the previous screen and to think again about our big picture goals for doing this study. There is a target population. We're interested in knowing something about that target population. In our case, we're interested in knowing about their use of ADHD medications. We cannot talk to the entire population, right? It would take too long, it would take too much money. So instead, we draw a sample, right? And we talk to this subset of the population and we get information from this subset of the population, right? When we get data from this sample, we are going to look at what did our sample tell us, all right? What did they tell us about how often they're using ADHD medication and what kind of side effects they've seen and how it's affected their schoolwork? We're getting this information from our survey from a sample. And when we look at these sample statistics, these are the descriptive statistics we're going to talk about today, all right? And remember, they only describe the sample, not the population. The key thing here in remembering they only describe the sample and not the population, we know that whatever of these, in this example, 4 people in our sample said, cannot be exactly what's true for the target population, because all of these people, if we had talked to them, their answers would have been slightly different from these 4 people, and as a result, we would end up with a slightly different answer, all right? And that potential for that difference between what the entire population would have said versus what our sample said is this error, all right, the fact that we have sampling error, the fact that there's some systematic error in our measurement. So today we're focused on getting these sample statistics, all right, our descriptive statistics. And then in our next videos, we're going to start talking about how are we going to take what we learned from our sample, add some estimate of how much error we have, and use this information to draw an inference about the population. All right, so we're going to say later, not today, based on what my sample told me, and based on an estimate of how much error there is in my measurement, here is my best guess about what's true of the population. All right, so later we're going to learn how to use the information we learned from our sample to make inferences about the population. Today, though, we are just over here. All right, before we can make an inference about the population, we have to figure out what did we learn from our sample. All right, what did this subset of our population tell us? All right, and so that's what we're going to focus on today, figuring out what our sample told us and describing, all right, what our sample told us. All right, so let's talk about the kinds of statistics that we use to describe our sample. Before we can do that, there is one distinction that we need to make, and unfortunately I don't have this typed in the slide, so I'm going to have to use my horrible writing skills to do it. Up here you can see that this says descriptive statistics for categorical measures. When we start talking about statistics, we get away from that nominal, ordinal, interval, ratio terminology that we used when we were talking about measurement scales, and instead we're going to use two words that refer broadly to the kind of numbers that those measurement scales produce. Nominal data, or nominal response scales, produce categorical data. All right, and I think this distinction makes some sense because remember we said that with nominal measurement scales, you're asking people to categorize themselves, and the numbers that end up in our data set simply identify which category people put themselves in, like 0 equals male, 1 equals female, all right? The numbers indicate which category someone belongs to. When we have interval or ratio measurement for a specific variable, this produces what we are going to call continuous data. Sorry, this is so hideous. This continuous, what the continuous is referring to is this idea that if you have an interval response scale, that this is a continuum. All right, and increasing responses on this scale reflect increasing quantities of something. All right, so this could be how much you like something, all right, or how satisfied you are. But regardless, as the numerical response to this scale increases, it means that people are moving upwards. There's an increasing amount of how much they like something or how satisfied they are. This is not true, all right, of nominal variables. As you move from 0 to 1, for example, male versus female, that doesn't reflect an increasing quantity of something. It just means there were two different categories and people belong to one of them, and the number indicates which category they belong to. With a continuous scale, all right, and the same with ratio, like if you ask somebody how old they are and their age ranges, from 0 to 100 years, increasing numbers reflect an increasing quantity, all right, an increasing number of years that they've been alive. And so data that gets collected on interval or ratio response scales is referred to as continuous. When we talk about both descriptive statistics and inferential statistics, we're going to have different kinds of analyses that we do depending on whether the data is categorical or continuous. All right, and the reason being that the very nature of the numbers themselves is different. All right, and we saw this a little bit already when we looked at the mode, the median, and the mean. And we talked about if you have nominal, ordinal, interval, and ratio measurement scales, that with nominal you can report the mode, with ordinal you can report the mode and the median, with interval and ratio you can report all three. All right, this is because this is categorical. It gets a different kind of data analysis than when you have continuous data, all right, and you are able to do all three of these things. All right, and so this distinction between the kind of data that we have is going to affect the kind of data analysis that we do. And so when we talk about data analysis, it's always going to be divided into two categories. What do we do when the thing we're interested in was measured on a categorical, all right, nominal response scale? What do we do when the thing we're interested in is a continuous measure? All right, so it was measured on an interval or ratio response scale. All right, so we have to keep this these two types of data analysis that we're going to do separate. When we get to the inferential statistics and things get a little bit trickier with separating this categorical and continuous, I will have a table that I will find some way to put in the slides since I can't write it on the board, and we will refer to that table to help us figure out what kind of data analysis do we need to do based on whether the variables we're looking at are categorical or continuous. All right, but so starting now with the categorical measures. How do we do descriptive statistics when we have categorical data? So we have data that was measured on a nominal response scale. Here we are limited to reporting frequency information. All right, so how many people circled option A, how many people circled option B, how many people circled option C. All right, and this is going to get tied to what was just up on the slide, where when we collect data on a nominal or categorical response scale, we can report the mode. The mode is just whichever one was most frequent. All right, so first we assess the frequency of all the categories, and then we report what's most frequent. All right, if we want to measure of central tendency. When we are presenting these frequencies, that presentation is typically done using what are called one-way frequency tables and cross tabulations. All right, and I'll show you examples of both of these. A one-way frequency table looks at one nominal variable, all right, one categorical measure from the survey, and it shows the number of respondents who gave each possible answer to that nominal question. All right, next slide, I believe, has an example. All right, so here is a one-way frequency table. Again, something to preempt all the stuff that's going to happen here. All of the data that's going to show up in these slides, in these examples for this and for all the statistics that we do in class, is from a survey that I gave to my students the first or second semester that I was teaching here. So this is like 8 years ago, all right, data that I collected from my students. And that data I will, is already posted to Blackboard, I think. If it's not, I'll post it on Blackboard. So in case you want to practice doing things in SPSS, you can use that data set, use the SPSS handbook that's been posted to Blackboard that shows you how to do all of these things with screenshots, and you can double check to see if you got the same numbers as me. All right, but so that data is available and you can look at it. All right, so the survey that I gave my students was just a basic lifestyle kind of survey. Where do you go grocery shopping? How much do you spend on groceries? How much do you spend on restaurants, clothing, bars? All right, and then some demographic stuff like what year in school are you? Are you Greek? Do you have a boyfriend or girlfriend? All right, that kind of stuff. All right, so here is one question from the survey. When you go grocery shopping, where do you shop most frequently? This was assessed on a nominal response scale with 3 options. All right, people could choose Kroger, Walmart, or Larson's Big Star, which is now called Cash Saver Plus. And these are the answers that the people in my sample indicated. All right, so 34 people answered the survey. 17 people indicated they shop at Kroger most frequently. 17 people indicated they shop at Walmart most frequently. And in these one-way frequency tables, you will often see 2 columns, all right, one column with count information and one column with proportion information. All right, so 50% is 17 divided by the total sample size. 17 out of 34 respondents said Kroger, so that's 50%. 17 out of 34 respondents said Walmart, so that's 50%. And no one answered Larson's Big Star as their most frequent place to grocery shop, and so that had 0%. All right, so very simple. All right, the one-way frequency table is like the most simple thing that you can report. It's just reporting count information. How many people circled each of the possible options to a nominal response question in my sample? Here is another one. All right, so here was a question: how many nights per week do you eat dinner away from home? One thing that I want to point out here, this was measured on a ratio response scale. All right, so the question asked, how many nights per week do you eat dinner away from home? There was a blank line. They could write in numbers between 0 and 7. As you guys saw in that table on the previous, a couple of slides ago, we had mode, median, and mean. With a ratio response scale, you can report all 3, which means that while we could take the average of these numbers, we could also report this count information. how many people answered 0, how many people answered 1, 2, 3, 4, 5, 6, 7. All right. If we wanted to report the mode, we would have to pick out which one got circled the most often. Here in this case, the mode would be 4. All right, and so in our one-way frequency table, we have the possible answers here in the first column, the number of respondents out of the total sample size of 34 who checked each of the possible options, and then that frequency converted to a proportion. All right, so 2 divided by 34 is 5.8%. 2 divided by 34, 5.8%, etc. All right, until we see 100% of the sample represented over here in the proportion column. All right, so if you have categorical data, all right, data that was collected on a nominal response scale, you have to report frequencies, all right, in terms of this descriptive statistic, all right, and you can report the mode, which one was most frequent, but you cannot report the mean. All right, so if you have men and women and you want to know what proportion was male and female, you can report those frequencies, but you cannot say on average people were 1.2. All right, if males coded 1 and females coded 2, because that doesn't make any sense. 1.2 doesn't correspond to an answer. So if you've collected categorical data, you are limited to reporting frequency data. However, if you have collected continuous data, you can report the median or the mean, which we'll get to on the next couple of slides, but you can also, if you want to, report this frequency information, if you think that it's helpful, all right, for interpreting your data. Cross tabulations look at the responses to one nominal question in relation to the responses of one or more other nominal questions. All right, so we're still in this categorical data working here, but what we're doing now is we're going to set up a table so that you have, let's say, male versus female, but also not just how many people were male versus female, but how did these men and women answer where they shop, all right, at Kroger, Walmart, or Larson's Big Star. When we set up a table like this, we are looking at the answers to one question in relation to the answers to a second question. All right, so how do these two things combine to affect the answers that we saw on our survey? All right, and so when we do this, this is called a cross tabulation. When we set up this cross tabulation, this is sort of preparing us for doing chi-square tests later, which are a new kind of statistic that I'm going to show you guys. But when we set up these tables, typically what we'll call a predictor goes at the top. All right, so in this example of does gender predict where people grocery shop? Our predictor would be gender. All right, does someone's gender predict which grocery store they go to? We're going to put that predictor at the top in the column headers. All right, and these predictors tend to be demographics or lifestyle characteristics, but as we'll see in an example, they don't have to be. Anything on your survey can be a predictor. All right, and then the outcome variable of interest, so the thing that these people are doing, all right, in this case where they're grocery shopping, goes as the row headers, all right, in the left of setting up this table. And this is often going to be some consumer behavior, people's attitudes, or their intentions. And once we have this table set up, inside of this table, you often have either count information or proportion information. And then at the bottom, you would have column totals. All right, so what proportion of the overall sample was male? What proportion of the overall sample was female? Overall, how many people shopped at Kroger, Walmart, and Larson's Big Star? All right, so you often see these column totals and percentages showing up on the outsides of the table. All right, so here are some examples of crosstabs from that data set that I was talking about, the survey of my students. All right, so we could look at a question like, does gender predict where people shop? All right, and so we have gender as the predictor variable, meaning that it goes in the column header, and we have where they shop as the outcome variable, meaning it goes in the row headers. All right, and so what this crosstab is telling us is that within our sample, 7 men said that they shop at Kroger most often, 9 men said that they shop at Walmart most often, while 10 women said they prefer Kroger and 8 women say they prefer Walmart. One thing that I want to point out here, because we're doing descriptive statistics, this question, does gender predict where people shop, does not mean like overall with students, does gender predict where people shop? It just means within the sample. All right, so within the sample, the answers that I'm seeing from the 34 people who took my survey, does gender seem to predict where those people in my sample say that they're shopping? Now remember that I said that any variable can be a predictor. It just depends on the kind of question you're asking. So another question we can ask about the people in the sample is, does where the people in my sample shop predict how much money they spend? All right, so I asked people, where do you shop most often? I also asked, how much do you spend? So what I've done over here is what's called a median split. I found the median dollar amount per month that students said that they were spending on groceries, which, by the way, like, wow, if I could spend 125 bucks on groceries in a month, that would be amazing. But what I've done is I've divided people's answers into two categories: people who spend less than average and people who spend more than average on groceries. All right, and so it looks like if you shop at Kroger, 7 people are in the less than average spending category and 10 are in the more than average spending category, versus at Walmart, you see 10 in the less than average category and 7 in the more than average category. And here in this cross tab, I have added the column and row total information here so that we still see, because this is a median split, it's looking at people above and below the 50th percentile, so half of people are below and half of people are above. And we saw on the previous screen that half of respondents said they shop at Kroger and half of respondents said they shop at Walmart. So we see those one-way frequency information being preserved here in the table, but then we also see how does that Kroger shopping relate to how much money you end up spending, all right, inside this table. One thing that I want to say about crosstabs, because later I'll show you how to do these crosstabs in SPSS, and it's very easy, all right, to set them up, and it's an easy way to kind of explore what's happening in your data set, all right, so you can set up these comparisons between two variables and look to see, does it appear that there might be a relationship between these two variables where one is sort of predicting the other one. And because they have, you know, kind of interesting information, it's interesting to look at this data. It's easy to become overloaded with them. All right, so when you're making decisions about which crosstabs you should run, all right, when you're looking at your data initially, you should choose those column and row variables with your research objectives and hypotheses in mind. All right, so look at the things that you wanted to learn, all right, that list of research objectives, and then look at where can I use crosstabs to explore those research objectives that I have. All right, you should use your initial hunch as a starting point for the crosstab. All right, so like we have this question on the survey, have you ever used an ADHD medication without a prescription? And you might, based on you guys' secondary research, you might say, well, I think that Greek students are going to be more likely to have done that, because a lot of you guys cited a source, I think, that found that being white, being male, and being Greek sort of all influenced use of this medication. So you might say, well, I think that being Greek is going to predict use of this medication. So that can be like your initial hunch, all right, to just make this crosstab, look to see, does it look like there's a pattern there in your sample? In the crosstab, you should look for what is there, like does it look like there's a relationship, but also look for what's not there. All right, so if you really expect there should be a relationship between these two variables and you're not seeing the pattern that you expected, that absence of a pattern can also be information. All right, it's telling you that something unexpected has happened here and that maybe you should look into that more. All right, crosstabs can be used to check for obvious answers, all right, things like making sure that subjects were paying attention. If you recall in the last set of slides, preparing the data for analysis, we talked about how you should check for consistency across responses. Things like, do you have a dog? Yes or no? And how did that correspond to their question of whether or not they buy dog food? So in this crosstab, does having a dog predict whether or not you buy dog food? All of the action should be in these two cells, right? So if you have a dog, you should be buying dog food, all right? So you should see a lot of people here. And if you do not have a dog, you should not be I keep saying dying, you should not be buying dog food. So you should see a lot of action right here too. But if you have people answering in these two cells, that's potential for people not paying attention, all right? Because if they don't have a dog, there's no reason for them to buy dog food. And if they do have a dog, but they're not buying any dog food, I mean, I guess some people could be making it at home, but this would also, raise some flags about were these people paying attention to these questions when they answered them, all right? So crosstabs can be helpful for looking for that sort of consistency in your responses when you're working on editing and coding the data. This statement, be exploratory when initial hypotheses are refuted, it's here in the crosstab table, but honestly, this is true for any kind of analysis you're doing, descriptive or inferential, any of the kinds of statistics that we're going to learn this semester. Something has to predict consumers' behavior. All right, we're focusing on consumers' behavior, although anything we can describe as a consumption behavior. Students, if we want to stick to our survey example, students are taking ADHD medications for a reason, all right? They're not waking up in the morning, flipping a coin, and if it's heads, they take the medication, and if it's tails, they don't, all right? That would be just purely random. There would be nothing that would predict that behavior because we can't know what their coin flip was, but that's not what they're doing, all right? So something has to predict whether or not they take this medication, and so if you have an initial hypothesis, like, I think being in the Greek system is going to make people more likely to be using these medications, but you find that that's not there, all right, that the data just doesn't support that relationship, don't just say, oh, well, it's not that, all right, I can't possibly know then what it is that predicts it. Look at another variable that you've measured and look to see, does this other variable that I measured relate to whether or not people say they're taking these medications? All right, so you should be exploratory if your initial hypothesis is refuted. This, again, shows up here under crosstabs. It's true for everything. The data doesn't lie, okay? So one thing about doing research is that you have to accept what the research tells you. If you have done a good job of writing your survey questions, all right, you've done a good job of organizing your questionnaire so that hopefully you're eliminating all the biases that can stem from how the questions are written and the order that those questions are put in. If you've done a good job of drawing your sample, a good random representative sample, if your sample size is adequate, then you have to accept whatever the data tells you. All right, so many times every semester, students turn in papers at the end of the semester where they assumed that one group of students was going to be more likely to do something than another group of students were, and they don't find that in their data. So they find that perhaps being Greek or gender just does not matter, all right, as far as this consumer behavior goes. And so they'll write that because that's the result of their analysis. But then they'll add on this second sentence, but I don't think that's true. Your personal beliefs cannot overshadow the data when you draw conclusions about what the data is telling you. All right, you cannot write, the data tells us X, Y, Z, but I don't believe it. All right, that's just, it's just wrong. All right, it's just, what was the point of doing any research if you're just going to assume that the data is wrong once you collect it? All right, so there are lots of ways that the data can be wrong, all right, if the research was done improperly, but if you have done the research properly, you cannot conclude, here's what the data said, but I don't believe it. All right, we'll add here, data doesn't lie except when it does, all right, and that's the problem with small samples, all right, and so what we're going to find in our data set, we're going to have lots of problems with our data set. Number one, that we have this convenient sample, so it's not going to be, it was not randomly drawn, and it's not going to be representative of the student body, and because it's not representative of the student body, we're going to have some groups of students that are underrepresented in our sample. So we're going to have very small response rates from some kinds of students. And so then the analysis might come back and say there was no difference between these groups, but it's because there was such a small sample that it couldn't really detect any differences. And we'll get into that later when we talk more about inferential statistics, but data doesn't lie. The caveat here being data doesn't lie if you've done a good job collecting that data. All right, so if you've done a good job collecting the data, you need to just accept whatever the data is telling you. All right, so we talked about descriptive statistics reporting frequency counts. All right, so how many people gave each possible answer to a question. Another thing, instead of reporting how many people answered each possible answer, we might want one overall summary statistic that tells us on average what did people say? All right, and we already looked at these measures of central tendency before spring break, all right? So we talked about what is the mode, what is the median, what is the mean. We're going to refresh that a little bit here and talk about some additional things that are relevant. All right, so remember the mode is the most frequently provided answer. Okay, so that goes along with those frequency tables we were just talking about. The mean, we're going to see the equation on the next slide, but the mean is sum up all of the responses that you get and divide by the sample size. And the median, you put everything in order, all right, from smallest to largest, and then pick out the answer that's in the middle, all right, at the 50th percentile. And we already talked about when you can report each of these kinds of summary statistics. For the mode, you can report the mode when you have any kind of measurement. For median, you have to have ordinal, interval, or ratio, and for mean, you have to have just interval or ratio. All right, so if you've collected data on a nominal response scale, you cannot report the mean. All right, some additional things here. All right, here is the formula for the mean. Again, this is not the formula for finding the median, it's the formula for finding what's in the middle. All right, so which number in the list corresponds to being the middle? You take your sample size and add 1 and then divide by 2. So if your sample size was 99, you would say 99 plus 1 divided by 2 equals 50. 50 is not your median, but the 50th answer down the list, once you've organized them from smallest to largest, that's going to be your answer. All right, when we talk about the mean and the median, there is something we need to account for. This is, you guys as researchers, but also you reading other people's research. One first thing that we need to account for is how outliers affect the mean and the median. All right, so if we were in class, I would ask, does anybody know what the outlier is? And we would stand awkwardly for a long time. And then finally, a brave person would say, an outlier is someone whose answer is outside of the normal range of answers, and that is accurate. All right, so here is the normal distribution. This is what is called a probability density function, which is what this label over here means. And what's happening here in this normal distribution, just to explain real fast before we get into outliers, you can think about this line down here is representing, it's a number line that represents all of the possible answers that could have been provided to a question. And a probability density function is referring to how many people answered at each of these possible answers. All right, and so the taller the curve is from the bottom line, the more people gave this answer. So I'm going to be unable to draw stick figures here, but you can imagine these are lots of people, all right, who gave an answer here. And as the curve approaches the number line, that means that fewer and fewer people gave answers at these higher points. This is the peak of the distribution. This peak of the distribution is where the mode is. All right, so that's the most frequent answer. The most people are stacked up right here at this answer. When you have a perfectly normal distribution, meaning that this curve is symmetrical around this high point, your mode is equal to your median, which is equal to your mean. All right, so if you have a perfectly normal distribution, all three measures of average would be exactly the same, all right, right here at whatever that number is. Sometimes, though, you have anomalies in your data set that mean you do not have a perfectly normal distribution, and that affects these measures of central tendency. All right, so one thing that you can have in your distribution is an outlier. All right, so we can think about this tail as continuing down here. And an outlier would be one person or a very small number of people who gave an unusually large or an unusually small response to this question. All right, so most people were giving answer, in fact, 99.7% of people were giving answers that fell underneath this curve, but some small number of people, all right, or just one person, is existing way over here giving an extreme response. Now, what this person does is this person's presence affects these measures of central tendency. All right, the mode is not going to change because this person existing over here does not change the fact that the most people still answered right here. All right, so the mode is going to stay exactly the same. The median and the mean, though, are potentially going to change. All right, and how the median and mean change is what we're interested in here. All right, so the presence of an outlier, if we think about all these people's answers, let's say we organize them from smallest to largest, and we ignore the outlier. All right, let's say these are the answers that we have. Well, we would have a lot more 3s here in the middle because it's the most popular answer. The median would be 3. All right, so in the middle of this line of numbers, we have a 3. If we add this outlier in, all right, let's say his answer was 10 here at the end of the list. When we calculate the median, we just move 1 down the list, and our median is still 3. All right, so because so many people are answering here at the middle of the distribution, the fact that we have now added 1 person to the end of our list of answers organized from smallest to largest means that instead of reporting this person, we are now reporting this person. All right, but all of these people still answered right here, giving the exact same answer in the center. Sorry, this is starting to get really ugly in the middle here. All right, all these people are still giving this same answer right here in the center of the graph. And so our median is not going to change very much. If it does change, it's going to change just a tiny little bit. It's going to move in the direction of that outlier. The mean, on the other hand, is going to change more drastically because of how the mean is calculated. All right, so remember, we calculate the mean by adding up all of these numbers and then dividing by the total number of responses that we got. All right, and so what happens is we have the numerator, right? We have the sum of all of the answers divided by the sample size. When we add in this outlier, the numerator is going to increase by a lot, all right, because this person's x, this person's answer is a much larger number, and so it's going to increase this numerator by a lot, but the denominator is only increasing by 1. All right, because it's just this one guy being added down here to the denominator. And so the mean is going to get bigger because this top number is going to get a lot bigger. This bottom number is going to change almost not at all right, negligibly. It's going to go from 1,000 to 1,001. All right, and so because of that, the mean is going to get pulled in the direction of that outlier. All right, so if you have an outlier who's giving an uncommonly large answer, then your mean is going to get larger. And if you have an outlier giving an uncommonly small answer, your mean is going to get pulled in that direction. All right, you're going to end up with a smaller mean. The implication of this is that if you're aware that in your data set you have an outlier, it is recommended, all right, it's more appropriate for you to report the median as your measure of central tendency than the mean, because the median is relatively unaffected by the presence of this outlier. All right, and so the mean is being unnecessarily affected, all right, and the average person looking at these numbers won't be aware that this outlier exists or that they should take into account the influence of this outlier, and so the mean can be misleading, all right, and so because of that, it's better to report the median. Okay, I'm going to say, do we feel okay about this? But none of you guys can answer me. All right, so the outlier is one thing that we have to worry about, the presence of outliers in the data set, because those outliers can affect our measures of central tendency by dragging the mean towards them. Another thing, if I can erase all of this, another thing that we need to worry about is the presence of skewness in our data set. All right, skewness has a specific statistical meaning. All right, oftentimes I think that people hear the word skewed and they think that it's like just means wrong. Like if you say somebody has a skewed perspective on something, that means they have a wrong or a biased perspective. That's not what we're talking about when we talk about distributions. What skewness means is that instead of having just one outlier, you have what's called a long tail. All right, so over here on this side, we can see that we have this relatively short tail, right, that's coming down, sloping down towards the number line, meaning almost nobody answered at this very low value. But over here on the right side, we see that this tail is extending. And what this means is that it's not just one person over here giving an extreme response. It's a series of fewer and fewer people giving these more and more extreme responses, but there's some number of them, all right, at increasing and increasing values of whatever this thing is that we're measuring. And so while there's not a lot of them, they do exist, all right, and they exist for every level over here at the right side of this tail. Now, just like an outlier, this is going to do the same thing, all right. The mode is going to remain unaffected because the mode is simply whatever the most frequent answer is. All right, so the presence of these people over here creating a right skew in our distribution does not change what the most popular answer was. So the mode is unaffected. But what it does is it pulls the median over a little bit because each of these people means that we're moving down that list of answers. And so the median starts to increase as we work our way down that list. But it's pulling the mean over even more, right? Because these people are influencing the numerator a lot, right? All of their extreme answers are influencing the numerator a lot, but they're only influencing the denominator by a little bit, right? Because while they're giving potentially very extreme answers to this question, there's not a lot of them, all right? So the vast majority of respondents are still answering in this range of the scale, right? But there is a smaller and getting smaller and smaller quantity of people giving these more and more extreme answers. All right, and so they pull the mean towards them, which means if you have a skewed data set, if your data set has a right skew, meaning it has a long right tail, all right, or it's left skewed, meaning it has a long left tail, you should be reporting the median, all right, because the median is less affected by that skewness than the mean is. One example of this in the real world, where we see this all the time, is, oh Lord, let me get rid of all this, is talking about income. All right, so here is the census has provided this graphic showing population as of, household income as of 2015, all right, for people living in the United States. And what we see is the beginning of a normal distribution here, but this has a long right tail, all right, because we have the vast majority of people, all right, so somewhere around in here you would have like the 75th percentile, all right, so around 80% of all Americans are making, I think it's below $75,000 or $90,000, something like that. All right, so the vast majority of people are making this dollar figure that is below that amount of money, but we know that there are people who make more than that. All right, so you have your doctors and your lawyers and your athletes, and then you start having like movie stars and elite athletes and your Warren Buffetts and your Jeff Bezos and everything way over here. And the presence of these people, and especially if you think about like Bezos over here and the amount of money that he's making, or Bloomberg has been all over the news for the amount of money that he has, one person having, well, his income wouldn't be $1 trillion, but a net worth of $1 trillion means that you are adding $1 trillion to the denominator of this average income, but only adding 1 to the denominator when we're trying to calculate the average. All right, and so what that means is that if we look at average income and we report the mean is going to get pulled in the direction of the people in this right tail, whereas the median is going to be relatively less affected. I am looking in my, I don't have it written down. Somewhere I have a note card that says what median and mean income are, so you can see the difference. I want to say that the median income was around 65,000 and the mean income was around 86,000, but I could look that up and double check. But what that means is that if you are thinking about legislation or what is affordable for people, whether you consider median household income versus mean household income is going to make a big difference. All right, and so if you have something that you're measuring that has this kind of skewness, you should be reporting the median, all right, because that's going to be a better representation of what really is average. All right, in this case, the mode would be this dollar amount, all right, close to, this looks like this is maybe close to 20-something thousand dollars. At the 50th percentile is $53,000, but then the mean is going to get pulled in the direction of all of these increasingly larger dollar amounts. So it's not just household income that has a right skew. It would also be things like net worth, even things like home prices. So in any retail market, when you guys graduate and might be on the market to buy a house, if the economy rebounds, you have a lot of houses in an area that all cost roughly the same amount. All right, so for example, in Oxford, you guys might not have ever tried to buy a home here, but most of the houses here cost between like $150,000 and maybe $350,000. So you see the vast majority of houses falling into that category. But then of course, there's all the areas around the square, right, where the homes are going for multi-million dollar homes. That's the right skew in the tail. It's not just one house, all right, that costs a lot more money than all the rest of them. It's that there are little pocket neighborhoods, all right, where you see a lot of really high value homes that create this right tail in the home price distribution, all right. And so then when you see reports about livability factors for different cities, you will typically see median home price being reported because that median is less affected by the presence of all of those very expensive homes and is instead better representing the true average cost of buying a home in that neighborhood. All right, so to summarize, if you think you have outliers in your data set, if you have skewness, so you have a long left tail or a long right tail, you should be reporting the median, all right, and you should be making sure that other people are reporting the median in those situations as well. Last descriptive we need to talk about is measures of dispersion, all right, which is talking about variance or standard deviation, all right, and I'm not going to focus on how to calculate this by hand because, to be completely honest, I would have to go look up the formula. All right, I don't know how to calculate it by hand. SPSS just does it for us. But conceptually, I want you guys to understand what variance is referring to. All right, so what variance is referring to is how spread out, all right, or how dispersed, that's the dispersion part here, how spread out were people's answers to a question, all right? Did people, let's say these are all the possible answers on this number line, did people tend to all give very similar answers to a question, all right? So there's not much spread down here. There weren't very many different answers that we saw, and we saw most people giving very similar answers. Or was there a lot of spread in people's answers? All right, this is a horribly asymmetrical normal curve here, but were there a lot of variety in the responses? So you were seeing a big range of responses, and it wasn't like everyone gave the same answer. People were sort of spread out all over the place. There were people giving all kinds of answers. This bell curve describes low variance. There is not much variability in people's responses. Everyone tended to give the same, 1, 2, 3, 4 responses. Almost everyone was answering in the same way. Whereas over here, you have high variance. There is a lot of difference in the way that people were answering their questions. All right, and so it's these patterns that tell us, that the variance is telling us about. And this means that if we look at the variance for a measure, all right, if it's hard to look at a single number and get some understanding of the variance, but if we have, let's say that we wanted to know how often two groups of people are taking ADHD medicine and we're comparing men versus women, if the men's variance response was higher than the women's, the variance in the women's responses, that tells us that the men's answers were more sort of spread out. We were seeing high and low answers, where the women's answers tended to all be clustered around the same number. So the women are pretty consistent in their responses, and the men are giving lots of different responses. On the next screen, we'll see a sort of practical example of why we might care about this. Okay, so let's say that we are a beer manufacturer, or, well, this needs to be a smaller thing, like we're a microbrewer, and so we're trying to open a retail location, and we have measured beer consumption in 2 different markets to try to get a feeling for which of these 2 markets would be better for us to enter. And so I'm going to show you the raw data in just a second, but in both markets, let's imagine that average beer consumption per week is 3 units. But we have this additional information that the standard deviation, which is a measure of variance, is 2.7 in market 1, and it's 3.7 in market 2. All right, and so this is, in class, I would wait for you guys to tell me an answer, but maybe at home you can just think to yourself, what does it mean that the average is the same in both markets? All right, so in the absence of any additional information, we might look at this and say, well, the average is the same, so it doesn't matter which market we enter. But we should also look at this variance information, because what this variance information is telling us is that over here, more people's answers were right around 3, whereas over here, the answers are more spread out. All right, so we're seeing some low answers, some high answers, and on average, that becomes 3. All right, so here's the actual data. We see over here in market 1, most of these answers are right around 3. We have one outlier. Over here in market 2, we see a bunch of low answers, one number at the mean, and 2 high answers. All right, and here's an example of these 2 high answers pulling the mean in their direction. So even though the majority of people in the sample answered 1, if we had looked at the mode here would have been 1, the mode here would have been 2. All right, so that would have given us some different information. Here, the median would have been 1. The median over here probably would have been 2. All right, but the mean in both cases is 3 because the mean is getting pulled in the direction of these outliers. The standard deviation is giving us this information that over here in market 1, most people are answering around that mean, whereas over here in market 2, there's considerable variation. All right, people are giving answers that deviate from that mean. All right, and in terms of attractiveness of these two markets, I mean, there's not a specific best answer, but I would argue that this market is more attractive because you have more potential customers in the marketplace consuming a number that is close to average, whereas over here, basically all of your sales would be dependent on the presence of these two consumers. And if those two consumers left the market for any reason, now you have, basically no sales to rely on. All right, so this variance is giving us some information beyond the mean about not just on average what did people say, but also overall how close were most people's answers to that average. A lower variance means that most people's answers are going to be clustered pretty tightly around this mean. Higher variance means that the answers are going to be spread out more. All right, they are not going to be as tightly clustered around that mean. Okay, so we have a sort of inelegant segue here because I didn't realize on the last slide that that was our last slide, but that concludes what we're going to talk about with descriptive statistics. The one thing that I just want to reiterate, the things that we've talked about in the slides so far are only about describing what the sample said. All right, it's not about making an inference about the population. To make an inference about the population, there are additional considerations that need to be made, and we're going to talk about those tomorrow, I guess, in the next video. All right, but before we get to the next video, I want to talk about graphs really fast because graphs are used to visually represent the data that the sample has given us, all right, to visualize those descriptive statistics that we just talked about. Again, this is probably going to be a review, but we will just have some fun, all right, looking at graphs. Here's some horrible statistics humor. Maybe we need a little horrible statistics humor today. All right, so we have a normal distribution and a paranormal distribution. Just laugh, give me a pitying laugh. All right, and then we'll move on to the next slide. All right, when we talk about graphically representing data, there are some main types of graphs that get used, and we're gonna, just review each of these. All right, we have line charts, which are especially useful for longitudinal data, pie charts and bar charts, and we will talk about 3 kinds of bar charts and how those differ. All right, looking at a line graph, here's what one looks like. Line graphs are useful, especially when you have 2 continuous measures. All right, so here we have how old someone is, all right, which is a ratio measure, and we're looking at as this thing increases, what tends to happen to this thing, and we see that there is roughly, an increasing linear pattern here, such that as the students in my course that semester got older, they tended to spend more money on groceries. All right, so this is a line graph. Here we have the average dollar amount spent at each age, and then we plot all of those on a line to look to see if there is a linear trend. All right, and that is the line graph part of this scale. The line graph part of this graph. Pie charts We're all familiar with them. The data from a pie chart comes from a one-way frequency table. All right, so here is that question that we saw in the beginning of the slides. How many nights per week do you eat dinner away from home? Here are the possible answers that people could give. Here's how many people gave each of those possible answers. Here's this information represented as a pie chart. All right, the reason why we use these pie charts is because this over here, this is a lot of numbers in a chart, and visually it's much easier and quicker to see this answer was the most popular answer. All right, so 4 was the most commonly given answer, and then you can see that there were some other commonly given answers, all right, 2 and 3, and then you can see that there were a series of less popular answers here. All right, like I mentioned, this is total review, all right, nothing new happening here. To look at bar charts, all right, we're going to use some data from that survey that I think is kind of the more interesting data, because students have a lot of stereotypes about how their peers spend their money. All right, so when I was writing the survey, one of the things that I was interested in looking at as a class example was how are the men and women in class spending their money. All right, and so if we want to look at effects of gender on spending, I'm going to show you some bar charts. Here is a table. Importantly, this is not a crosstab, all right, because this is not count information. This is just a table of means. All right, so the men on average said they spent $155 a month on groceries, $345 a month on dining out, and $112 on clothes. And the women said that they spent these average amounts. So it is perfectly fine to put all of this information in a table if you were writing a paper or giving a presentation or something like that, but it's a lot of numbers, all right, to look at, and visually it can be difficult to see where all of the differences here between these numbers are. So another way that we can visually represent this information is through a bar chart. All right, this is a clustered bar chart. Ooh, the writing's bad. All right, this is a clustered bar chart. The cluster here means that we have a cluster of responses for groceries, a cluster of responses for dining out, a cluster of responses for clothing, and we have the men's information and the women's information in each of these categories being presented. And what becomes clear here, which was perhaps less clear when we looked at these numbers up here, is that men and women seem to be spending roughly the same amount on groceries, but men are spending a lot more on dining out and women are spending more on clothing. Importantly, I'm going to say men and women, and what's implied here is the men in my sample and the women in my sample, all right, because again, these are descriptive statistics. What did the people in my sample tell me? Another way that we can visually represent this data is through what is called a stacked bar chart. All right, so instead of looking at these by category, like the clustered bar chart did, now we can stack the spending in every category for each type of respondent. All right, so what benefit do we get from looking at this stacked bar chart instead of a clustered bar chart? Oh, I think I hear someone in the distance said, it makes it easy to see that the men appear to be spending more overall than the women. All right, so we can see that when we add up all of these categories, the men seem to have excess spending, all right, compared to the women. All right, and so it's easy to see that in the stacked bar chart, not so easy to see that in the clustered bar chart. All right, just for the sake of example, all right, for looking at this data that I think is pretty interesting, we can look at effects of gender and relationship status on spending. All right, so when we make these bar charts and you have a clustered bar chart, you can cluster on as many factors as you want. All right, so in this case, we have the men, yes or no if they're in a relationship or not, and then their average spending in each of these categories. All right, normally in class, I ask you guys to make predictions. Where do you think the men, like when do you think the men are going to spend more money? When do you think the women are going to spend more money? People tend to predict that men in relationships are going to spend more on dining out and than men who are not in relationships, and that the converse will be true for the women, and that women in relationships are going to spend, what do people normally predict? Less on clothes, maybe? I don't remember about the clothes. That one's trickier. Let's look at these as bars. All right, this is a lot of bars, so it's a little hard to see the pattern here. All right, but what we see that's kind of interesting is that It is actually the men who are not in relationships in the sample who report spending more on dining out compared to the men in relationships. Whereas for women, it seems like being in a relationship doesn't really seem to affect their spending on dining out. One thing is that this dining out category includes not just spending in restaurants, but also spending in bars. All right, so one student summarized it succinctly one semester when they said that these men in this bar are thirsty. All right, and so they're at bars buying lots of drinks for themselves and for women. All right, potentially trying to enter into this in a relationship category. We look at some of these other bars. The grocery spending, all right, it doesn't look like there is much of a difference in grocery spending, regardless of whether or not you're in a relationship or not. When we look at clothes spending, these brown bars, people seem to spend more on clothing when they are in a relationship, regardless of their gender. All right, so if we look at this comparison and this comparison, being in a relationship means that you seem to spend more money on clothing. Sometimes students predict that being out of a relationship, you have to spend more money here to attract a significant other. The suggestion here seems to be that once these people have found a significant other, they spend more money on clothes to keep that significant other. A lot of the guys over here joke that once they have a girlfriend, their girlfriend makes them buy nicer clothing. All right, and so that's why they end up spending more. That's why they end up spending more on clothing. All right, but this is what your peers said 8 years ago anyway. Maybe I should update this survey to see what people are saying now about how they spend their money in and out of relationships. Okay, as with every other topic, I will belabor the point that sometimes people intentionally mislead audiences when they present this information. All right, and so presenting descriptive statistics is no different. People will sometimes use graphs. Sometimes I think they just are dumb. All right, they just make bad mistakes. Or we'll see one example where I think a graphic designer got too excited and made a bad pie chart. But sometimes I think that they're deliberately trying to mislead the audience. All right, and so as a consumer of other people's graphs, right, you need to make sure that you are still being a critical thinker, all right, that just because data is presented in a graph does not make it any more or less true than if it was presented, outside of a graph. All right, so you still need to think critically about what's being presented to you when you see this visual data. All right, as an example, here is a billboard, all right, for an American Express credit card that said that they were offering a tasty 5% cash back. All right, and then they have this kind of gross looking, honestly, pie chart that I think is supposed to be a pizza. All right, but the piece of the pie that they seem to suggest you're getting back is roughly 25%. All right, so visually, they are suggesting that you get a lot more than 5% cash back. It's kind of like a pizza that's also a British coin. I don't know, that's a weird graphic, but the content, getting 5% cash back, does not match the visual, right? And so this can be misleading to people who see this billboard. Here is an answer printed in a newspaper. All right, would you pay more for your milk to help dairy farmers? 87% answered yes, 13% answered no, and yet we have a pie chart that seems 50-50 split. All right, I think this was just dumb. All right, I think this was just somebody not paying attention when they made this graph. All right, but still, if you just glanced at this and did not take the time to look at the numbers, it would suggest that people were evenly split 50-50, and that's not what the data shows. All right, and finally over here, this is from Food Network's magazine. Around Thanksgiving, they asked, what are your 3 most favorite types of pie? The thing here is that pie charts are supposed to add up to 100%. This pie chart does not add up to 100% because people were asked their 3 most favorite types of pie, which means hypothetically this could add up to 300%. All right, and so while visually, you're still getting that apple pie is the most popular, 47% of people listed apple as one of their 3 most favorite types of pies. These proportions being shown do not correspond to the size of the pie slice that's being taken out. Plus, having all of these pictures of the different kinds of pies is visually very cluttered, and this is just a wreck of a pie chart, but somewhat clever, I guess, to show a pie chart measuring pie preference. Things can really get ugly all right, when people start to present things in line graphs and bar charts. And the thing that you want to be paying attention to, all right, when you're looking at line graphs and bar charts, when you're trying to see, is this misleading, is you need to pay attention to the y-axis. All right, remember the y-axis is the vertical one, all right, it's the measure of how much of the outcome people said, how much they like something, how much they're willing to pay for something, the number of people who did something. That often gets manipulated, all right, and so that's what you want to be looking for. As an example, here is an advertisement from the province of Saskatchewan in Canada. They were trying to report information that their province is growing, all right, that the population size is increasing. But what we see here is that they have really truncated the y-axis. So this number, this smallest number, is actually almost 1 million people. All right, and then we see what looks like really steep growth here, but they have only increased from 993,000. They've added about 200,000 people, well, less than 200,000 people. This vertical line suggests really massive growth, but it's because they've truncated the y-axis. This axis does not begin at 0. If in Excel I start the y-axis at 0, but I use these same numbers, we see a much more modest visual increase in their number of residents. All right, so they're not technically lying, all right? They're providing the raw data at each of these points, but the visualization of that data is not the best. All right, they didn't do a great job of presenting this. Let's look at another example. Here is a bar chart, all right, representing how concerned people are about the Zika virus. I don't know if you guys remember Zika. It was a thing, I don't know, 5 years ago, 6 years ago now. This is, I don't know what happened when this person made this bar graph, but we can see here that the highest number, 34%, is people saying they are very concerned, and yet this bar is not the tallest bar, all right? This bar is the tallest bar, corresponding to 13% of people who said that they were not at all concerned. This is actually the smallest answer. Somewhat has absolutely no bar at all, all right, despite being the second highest selected answer. I have no idea what was happening here. This is a wreck. This was a major disaster for this creating this bar chart. Let me erase this before the next example comes up. All right, paying attention again to the y-axis. Here we have a chart showing public and private sector jobs in Ontario. All right, and so it looks like private sector jobs are increasing, but public sector jobs are increasing even more rapidly to overtake private sector jobs. What's the problem here? Have a little Jeopardy music. Do, 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 do. All right, if you are looking at the y-axis, the orange line has a different y-axis than the green line. All right, so here, this orange line is corresponding to about 1,350 public sector jobs. This green line of private sector jobs corresponds to 5,500 private sector jobs. 5,500 is much larger than 1,350, and yet this green line ends below this orange line. Okay, this is a graph made by someone who is trying to make an argument that there are too many government jobs in Ontario. All right, so they have manipulated these y-axes so that they can show a graph that makes it look like there are more government jobs than corporate jobs, and that is not actually borne out in the numbers, all right, the raw numbers. All right, so this is manipulation of the y-axis. All right, this is what you should be paying attention to. This one was a doozy. All right, this one, this came up in the news probably when you guys were too young to care that it was happening, but this is a graph, I'm going to blank on the congressman's name who held this graph up in a presentation to Congress. All right, but this is a graphic that was created by Americans United for Life, which is a pro-life lobbying organization. And they were trying to make the argument that Planned Parenthood should be defunded by the government because all they do is abort babies. Okay, this was the argument that they were trying to make. And so they present what they are trying to claim is a line graph depicting that cancer screening and prevention services are decreasing while abortions are increasing. The problem with this graph, all right, as we saw in the previous graph about the government and private sector jobs, is that this red line is a different axis than this pink line, has a different y-axis. 327,000 abortions is a smaller number than 935,000 cancer screenings, and yet this number is a lower point on this graph than this high number. All right, the point that they're trying to make is that this number has increased to this number, all right, and this number has decreased to this number, but the way that they've drawn this line graph suggests that they have flipped places, all right, that Planned Parenthood is now giving more abortions than they're giving cancer screenings, all right, and so this graphic was printed and put on a big poster board and held up in Congress, and so it made a big splash in the news where people were just picking apart this bar graph. All right, and so let me erase all this stuff. So Vox decided to take the raw numbers and plot the raw numbers as they should look on a properly executed line graph, where you have 0 on the y-axis and the same y-axis for both categories that are being presented here. And so you can see that abortions are relatively, they're relatively constant. The objective number has increased, but it's not much of an increase, whereas cancer screenings and prevention services have decreased at Planned Parenthood, though they talk in the article, which I'm guessing none of you care about, and it's outside of the realm of us talking about statistics, but there's a reason why this number decreased. But then they say that the other thing that's misleading about this graph is that it does not account for the bulk of Planned Parenthood's business, all right, which is STD testing and delivering contraceptives, all right, and so when we look at those on the same y-axis, all right, in relationship to the number of cancer screening services and abortions, then it tells a much different picture than that original graph was giving about the role that Planned Parenthood plays in the neighborhoods that they serve. All right, and so again, this is not a pro-Planned Parenthood or an anti-Planned Parenthood or anything sort of thing. It's just about proper and improper use of line graphs. And when you are seeing these line graphs being presented in articles and in the news, pay attention to the y-axis. All right, make sure that the graph is appropriately plotting the data that they purport to be presenting. All right, so that this graph is appropriate. All right, I believe this is the end, all right, of these slides. I don't think I have any more examples here. So in the next video, when you guys come back, we are going to have a conceptual introduction to inferential statistics.